Page 5 of functions. In the reading, we found that the domain of a relation, and remember a relation can be a function but isn't necessarily. The domain of a relation is a set of x values in the relation, while the range of a relation is a set of y values in the relation. Let's use set notation to define domains and ranges for each one of these functions or relations. Let's see, number 1. Basically, it exists for the x values from -1 to infinity. So how do we express that with set notation? So we can put x such that, the vertical line means such that in math, x is greater than -1. Now should we put greater than, or should we put greater than or equal to? We'll look at the closed dot. If it's a closed dot, then we put greater than and equal to because it includes the dot. What about y? Y is going to be range from negative. Did you get my joke there? Y ranges from. Okay. Y ranges from -3 to infinity, so it's greater than or equal to infinity, such that. Okay. What about the parabola here? Now be careful because this circle here, it actually just means origin. You see they always put it there, origin. So this isn't like the empty dot, so don't get confused. So the x values here are all x values, and you don't write that x ranges from -infinity to infinity, although that wouldn't be incorrect. Just write that x is an element of the real number set. Okay. What about y? Y, is it all real numbers? No, because it doesn't exist above that point, which is 1. So y is less than or equal to 1. Less than or equal to because it includes the dot. Do you see the vertex? The vertex is also included, so it'd be less than or equal to 1. What about the hyperbola here? The x values that it exists on are all values except for this value, x equals 2. So how could we say that? We could say, you could say x is greater than 2, or x is less than 2, or you could say x is all the real numbers except x is not equal to 2, something like that. Okay? Or you could just say x is not equal to 2, maybe. Y values, all y values except for this y value. Y is not equal to 1. So y is all real numbers except y is not equal to 1. Okay. Alright, now we're going to use number lines to express these three domains. So again, we're going to use closed circles and open circles to show when the function exists. So like here, we said that it exists from x is greater than or equal to -1. So we're going to mark -1 with a closed dot, and then we're going to draw our red number line arrow to the right. The next one is all real numbers, so we're going to just draw a red line all the way from left to right with arrows at the end. The arrows in the end indicate that they go on forever. Third one, we're going to put an open circle at x is 2, indicating that the domain does not exist at x equals 2. Everything else is going to be a red arrow. Okay? Alright. A function definition normally requires a rule and a domain. If we are only given an equation, then we use the natural domain, which is the largest part of the real number set for which the function is defined. Give a function for which the natural domain is x is greater than or equal to 0. Okay, what kind of operation have we worked with that negative numbers can't be input into? Well, think back to our investigation. We used the square root function, right? The square root function can only accept numbers 0 and above. So this would be a function that would satisfy that condition. Okay. All right. For each of the following graphs, find the domain and range. So, like for this first one, D, X is all real numbers, right? All real numbers. What about Y? Y ranges from here to here, which is, let's see, Y ranges from, oh, and like, look at this, a little bit tricky. Do you see how the function approaches X but doesn't touch? Approaches X but doesn't touch. So here we're going to put 0 is less than Y, but we're going to use the less than sign, not less than or equal to, because it doesn't actually touch 0. On the other hand, the function does touch Y equals 2, so we put greater than or equal to for that one. Okay, next one. So this is a parabola, our old friend, the parabola. The domain would be all real numbers. The range would be numbers greater than or equal to -1. Because it does touch Y equals -1, right? What about G? Now, if this was like this, it would be all real numbers for domain and range, but it's not. It has like a closed dot there. It stops. So the domain would start here, which is -4, and the range would start from -3. And I would put greater than or equal to in both cases because it's a closed dot here and not an open dot. H. So the X values looks like it ranges from -infinity to infinity, so I'm going to put X as all real numbers. Y looks like it starts at Y equals -2. Now the question is it greater than -2 or is it greater than or equal to -2? And you can see this dotted line here. It indicates an asymptote. So the function approaches the asymptote but never touches. So it would be greater than -2, not greater than or equal to -2. I. So you can see that there's certain places on the domain here that are not part of the domain, and that would be X equals -2 and X equals 2. So here we could give it as, let's see, X is less than -2. X is less than -2, X is greater than 2, and also X is between -2 and 2. And you have to be really careful about not trying to put those all in one expression. Use more than one expression. Okay, or use more than one inequality. What about the Y values? The Y values look like, and we need to zoom in here. Do you see how like it starts at -1 here? So there's a band between 0 and -1 that Y does not exist on. So we could say, to be really specific, that Y is greater than 0, and it's greater than 0, not greater than equal to 0, because it never touches the x-axis, right? It's an asymptote. And then if you look at the bottom, it's going to be Y is less than or equal to -1, because it actually touches -1, right? So that would be the domain, or the range. Okay, last part, 2. State the values of x for which f of x is defined, and hence state the domain of the function. Okay, so like for example, for this one, whatever is inside cannot be less than 0. Otherwise, the square root function doesn't work. So we're going to put x plus 6, which is the inside part, and we're going to say this has to be greater than or equal to 0. And so what does x have to be to make that true? Let's use algebra. This is the way you can do it so that you just don't get, your negative signs backwards and stuff. So x is greater than or equal to -6. Wasn't that easy? Algebra is your friend. This notation here is the same thing as the function notation. It's the same thing as writing f of x equals 1 over x squared. They're trying to get you used to alternative notations. So here, the only illegal values for x would be, or the only legal values here for the denominator would be 0. So x squared, let's see when x squared is equal to 0, and that would be exactly what we don't want. Okay, so like x squared equals 0, the only solution to that is x equals 0. So basically what we're saying is x is not equal to 0, but x is from the real numbers, okay? All right, C. So here we need to say, oh, well, 3 minus 2x has to be greater than or equal to 0. And then so we're going to use algebra here to figure out what exactly that means. And we're going to get that. Now be careful, because here we're going to divide both sides by -2, right? I don't know if you remember, but if you divide both sides or multiply both sides by a negative number, it reverses the inequality. So now we're going to get x is less than or equal to 3/2. Now, if you're wondering why that happens, take the following. If you have 1 less than 2, which is perfectly obvious, what if you multiply both sides by -1? Seems perfectly harmless, right? You get -1 is less than -2. Oh my God. So you multiplied the same thing on both sides, which would not break an equality, but for an inequality, it makes it the opposite. You see, just multiplying by negatives on both sides, we see that the inequality is reversed. We need to reverse it. And if you look at a number line, you can kind of see why that's true, right? If you have a number line and you have like 1 and 2, and then you multiply both by a negative, then basically what you're doing is throwing them on the opposite side of the number line. And now, do you see how, you had 1 that's less than 2, you can no longer say -1 is less than -2 because now they're reversed on the number line. Okay, so keep that in mind. Whenever you multiply by a negative number on both sides, you're going to have to reverse the inequality. And I have a poster at the back of the room which says that. Okay, that's it for this